everybody, how is it going? Today we are going to learn about something called intermolecular forces, also known as IMFs. All right, so let's talk about what this word means, intermolecular. Well, we know that molecular means molecules, and inter, what do you think inter means? Inter typically means between. So if we have an intermolecular force, we have a between molecules force. So that's exactly what intermolecular forces is. Intermolecular forces are the force of interaction between two molecules. Okay, so I'm going to explain a little bit about intermolecular forces and then something else called intramolecular forces. So I'm going to flip to the back side of this so I can explain a little bit better. But what I want you to imagine is I want you to imagine a beach and what you would bring to a beach. What's something that you would bring to a beach? A towel. So let's say that you have two small pieces of towel and you want to combine them to make one large towel. So we're going to say that our towel is made of two pieces. And we're going to say that these two pieces, for example, would be like hydrogen. So here's one small piece of towel. Here's the other small piece of towel. So hydrogen, chlorine, there you go, there's HCl. Okay, now let's say that these two small pieces of towel you want to combine to make a larger piece of towel, and you want that towel to be permanently larger. So what are you going to do to make these two small pieces of towel permanently larger? Well, you're going to sew them. So we're going to say that this is our little sewing. So in order to put these two things together, you're going to have an intramolecular force. And intra means within, so inside. So an intramolecular force is a force within a molecule. So intramolecular, these are the bonds. So the ionic bonds that we've already learned about, the ionic bonds and also covalent bonds we've already learned about. Positives and negatives, two nonmetals together. So the intramolecular forces are the forces within a single molecule. Now let's say that you go to the beach with your friend and your friend did the same thing with their towel. They sewed together two small pieces of towel to make a large beach towel. And they also have a wonderful hydrogen towel and a chlorine towel. So there's HCl. Now let's say that you guys don't want any interaction with the sand, and you want to put these two large towels together. Well, something you could add to these towels is you could add Velcro. So we're going to say this is the Velcro right here. You could add Velcro to Velcro these two towels together. Well, this would be like representing the intermolecular force, right? The force between these two sets of molecules. These sewn together towels are like molecules. So the intermolecular, you have these two pieces of Velcro. Now the thing with the Velcro is you can put them together, but you can also take them apart. Whereas these things that are sewn together, they're going to be a lot harder to take apart. Velcro, you can just rip apart. The sewing, once it's done, it's going to take a lot more energy to break that bond apart, whereas the intermolecular force might not necessarily be too difficult. So this is my little analogy to kind of show you the difference between an intramolecular force, which are like the ionic bonds, covalent bonds, and the intermolecular force, which is the force between this molecule and this molecule. All right, so back to our notes. So intermolecular forces are compared based on their relative strength. So there are a couple types of intermolecular forces that we're going to talk about. And the first type of intermolecular force is a dispersion force. And dispersion forces, these are weak. These types of bonds, these types of forces are weak. Some examples. All right. So Like what I just said, dispersion forces, these are weak. Two examples of dispersion forces are chlorine, so Cl2, let me rewrite that as it looks bad, Cl2 and Br2. These are called diatomics, if you remember. So in Cl2, it's a diatomic molecule, so chlorine cannot exist by itself. If it's alone in nature, it has to bond with another chlorine. Same thing with bromine. They can never just exist as just a Cl or a Br. They have to be with something, and if there's nothing else around, they're going to bond with themselves. Now, between the two of these, bromine is stronger than Cl2 because there's more electrons. So bromine is a bigger atom, has more rings than chlorine, more electron levels than chlorine. So the more electron levels it has, the stronger the force is going to be. That's something you're going to want to remember. All right. The next type of intermolecular force is something called dipole-dipole, and these have moderate strength. So they're in the middle. And an example of a dipole-dipole compound would be HCl, hydrogen chloride or hydrochloric acid. So these are second in the list of the three. The last is hydrogen bonding, and hydrogen bonds are strong. And an example of something that has a hydrogen bond would be H2O. So when multiple water molecules are bonded, they're going to be bonded by the hydrogen, and that is considered a strong bond. Now, this is also what you're going to find in our lab is that hydrogen and water has a hydrogen bond. You think about the surface tension of water, it's very sticky. Water is very sticky. It likes to stick to things. It likes to stick to you. It likes to stick to itself. So water is sticky, and that's because it has strong hydrogen bonds. Now, we have also talked about ionic bonds before, so you need to add this, ionic bonds, and these are the strongest, okay? Mostly because these are all nonmetals, and ionic bonds deal with metals and nonmetals, and opposites attract, so metals and nonmetals obviously have opposite charges, so these are going to be the strongest. All right, so let's talk about IMFs. And IMFs have tremendous effect on the physical properties of a molecule. So melting point, the melting point is the temperature at which a substance changes from solid to liquid. So it's the temperature when something begins to melt. That's pretty easy, pretty obvious. Boiling point, what do you think boiling point is? Yeah, boiling point is the temperature at which a substance changes from a liquid to a gas. Very easy. All right, third is vapor pressure. And vapor pressure is also known, AKA, as the rate of evaporation. So the rate at which something evaporates. Okay, so if something has weak intermolecular forces, weak IMFs, thing is going to have a faster evaporation rate. If it's strong, it's going to evaporate slow. So let's think about, when you're at the doctor and they rub you with an alcohol pad before you get like a vaccine or a shot, or they have to test you for something. Think about that alcohol pad, and when they wipe you with it, it evaporates right away. Versus if they were to take something made out of water, it's going to take a little while for it to dry. That's because rubbing alcohol, which is on those pads, alcohol has weak intermolecular forces, whereas water has stronger intermolecular forces. All right, and last but not least is surface tension. And surface tension is the attraction of liquid particles to each other across its surface. So basically it's just saying that liquids that are sticky, that like to stick to one another, they have strong intermolecular forces. So the stickier a liquid is, the stronger the intermolecular force. For example, water. If you were to dip something in water and pull it out, water molecules are going to stick all over that item. If you have a cup of water and you pour it out, there's always water left behind. You jump into a pool, you jump out, you shake to get all the water molecules off. A lot of them are still going to stick to you. So water is super sticky. That's because it has greater surface tension, and the greater surface tension something has, the stronger the intermolecular force. And I also should mention with melting point and boiling point, the higher the melting point, the stronger the intermolecular force. The higher the boiling point, the stronger the intermolecular force. So if we were to put all of that together, the greater a molecule's IMFs, the greater its physical properties, like melting point, boiling point, the rate of evaporation is slow, and then surface tension, greater surface tension. All right, so let's take a look at these these questions right here. It says, of the three liquids below, substance A, B, and C, A has only dispersion, which we said over here are weak. B has dispersion and dipole-dipole, which has both of these, and then substance C has all three. So which of these three do you think has the highest boiling point? Well, we said things that have hydrogen bonds have strong intermolecular forces. So high boiling point, like I just mentioned, the higher the boiling point, the stronger the IMF. So which of these three do you think has the highest boiling point? Well, that's going to be substance C, because substance C has all three of the intermolecular forces, and it includes the highest one, strongest one. Which will evaporate the fastest? Well, we have to think about vapor pressure. So if something is going to evaporate faster, it's going to have weak IMFs. So which of these three has the weakest? A. Dispersion is the weakest of the three, so which is going to evaporate the fastest? It will be A. All right, so to summarize, let's talk about this really fast. So as IMFs, as intermolecular forces increase, so the stronger melting point, boiling point, surface tension, so does the energy required to melt, boil, vaporize, etc. The greater the force of the bond, the harder to break that bond. Okay, so if any of these are super strong, super high, then your intermolecular forces are going to be greater, therefore stronger.